for standard deviation. The closer your data is, the more bunched up your data is, right? If you have a bunch of data that's bunched up together, real close together, you're going to have a smaller standard deviation. If your data is real spread apart, your standard deviation is going to be larger. Why is that? Remember, I told you that the standard deviation is how far, on average, each entry or data point is from the mean. Okay? Like the average distance each point is from the mean. Or the average variation from the mean, one might say as well. Alright? So here's a picture of that. Yay. Let's write a data set that has 10 entries, a mean of 10, and a population standard deviation that is approximately 3. Well, we have a good solution for this. So what would that look like? Oh, actually we don't have it. So let's go ahead and do this. There we go. Every one of these has had an answer on it except for this one. Alright, the mean is 10. I'm going to get out my handy-dandy calculator. So let's see if we can make a data set that's like that. So let's call this, I don't know. I just feel like calling it Storm. Since it's one of those days. Alright, hey. Okay. Standard deviation should be around 3, right? Mean should be 10. So if I put 10 in there, the mean is already 10, right? If I have a bunch of 10s, the mean is going to be 10, right? So what if I put 10, 10, 13, 13, 12, 14? What do you think? On average, are these about 3 on average? 3 units from the mean if the mean is 10? I don't know. Let's calculate it, right? So I have my Lesson spreadsheet. Let's go doc. Huh? Oh, did it say 10 numbers?
Yeah, it has 10 data entries.
Okay, let's get 10 data entries in there. Okay. So we went 12, 14. I mean, if I put another 10 in, it's not going to change anything, right? I could put in a 13, and then I could put in a 12 and a 14. I have a feeling that's going to be about what we want. All right? Let's hit doc. Insert. Let's get a calculator because I want to know what my mean and my standard deviation are. So I'm going to hit menu. Statistics. I want stat calculations. I want one variable statistics. Number of lists is going to be 1. My X list is Storm. Storm and Dorman. What did we get? What did we get? Ooh, my standard deviation's not right. Ooh. My X bar is 12. Should have left it. Alright, okay, it's okay. That's okay. Let's modify it. Let's see. What do we need to do? Well, let's make this a 10 instead. Whoa there, tiger. I'm gonna make that a 13. I'm gonna make that a 10. And then see, the mean's not gonna be the mean. Oh yeah, I'm so silly. Why was I doing? Yeah, I'm sorry. I don't know why I was not putting lower numbers. 13, 13, 13. Let's go 7. Sorry. 7. I think that's going to look much better. Sorry, I was weirding myself out with that. So I think that we can go up and we can hit enter again. And there we go. Wait, maybe. All right, our mean is 9.7, not bad. Standard deviation is closer to 3. It's looking much better. All right, I apologize. For some reason, I put in the 12, and then I was going 1 above and 1 below 12, instead of going 3 below and 3 above 10, right? That's what's going to give us the standard deviation. If on average, our entries are 3 away from 10, but we have enough that we get to 10. Okay. All right. Awesome. I think that was close enough. Whoa. Here we go, guys. This is a big discussion. Guys, if our data has a symmetric distribution, okay, a bell-shaped distribution, many times this is called a normal distribution. In fact, this rule applies to a normal distribution. Alright, sorry, I was trying to get this. There we go, now we're good to go. Alright, sorry. Alright, guys, let's talk about this real quick. And we're going to get into a normal distribution in super detail in this class later on. But there you go. Here's our normal distribution, all right? With the normal distribution, it's perfectly symmetric, so the mean is right in the middle, right? It turns out that our first standard deviation is going to be right here where it seems to turn for the first time. So what this is saying is that if we have a bunch of data, 68% of it is right here, okay? There's another turn here, somewhere around here. So this is one standard deviation away, okay? Here's 2 standard deviations. Right, we said standard deviation, we're using that sigma, a little weird O-ish looking sigma. Huh? Sigma? Yeah. It's all sigma. And then over here, we're at 3 standard deviations away. Yeah. So this is 95% of my data is in there. And then between here and here is 99.7%. That's what that means. That is a picture of what this is saying, okay? If I have a bell-shaped curve, 68% of the data is within 1 standard deviation, 95% within 2 standard deviations, 99.7 within 3 standard deviations. That's a picture. Okay, so, oh wow, their picture looks really nice.
Oh, nice.
That is a nice picture as well. And they're just writing it as x minus 1 standard deviation, right? And I just kind of call it 1 standard deviation in the positive direction or in the negative direction, either way, right? You can also cut it apart like this. So this is a nice picture to have. I think you should put this. So it's another way of representing this. And it makes sense, right? You'll have 34% here, 34% here. That's 68%, right?
Yeah, like 19 and 19, 15.
So this is actually a helpful picture to have written down as well.
I remember that from church.
Okay, so let's try it ourselves. A sample mean. So sample mean. If I see sample mean, I think boom. Okay? I think X bar. Alright? This is the symbol that means sample mean. It says it was 64.3 inches, so that means that X bar is 64.3. It's got a sample standard deviation. Sample standard deviation. What symbol does that make me think of? The Spider-Man symbol? No. It makes me think of this one, right? S of X. It tells me it's 2.62 inches. What percent of women's heights are between 64.3 and 66.92 inches tall? There's an answer down here, but I want to make a picture for you guys so that you can see what's going on with this. So it's the same kind of picture that we had before. It's not the best looking normal curve. But now I said my mean is right in the middle, right? The mean is right smack dab in the middle. So that should be 64.3 if that's my mean. 1 standard deviation away in this direction, right, is going to be my mean minus my standard deviation. So we'll go 64.3 minus 2.62. And we have, so right over here we have 61. If this is 1 standard deviation away, right? Then this is 61.68. You see what I did? I just subtracted the standard deviation from my mean, and I got this point right here. So there's 1 standard deviation below the mean. 1 standard deviation above the mean is going to be 64.3 plus 2.62, which is going to give me 66.92. Okay. Hey, what's true about in here? 68% of the data is in there, right? So what's true about in here? How much data is over here? Because this is what we're being asked for, right? We're being asked for how much data is between 64.3 and 66.92. So if we're going to look at this picture that we had before, right? So 34% is this piece, and that piece is 13.5%. So, right? So we said this was 34%. This was 13.5. So you want to go 34. plus 13.5, which is going to be 47.5%. For me, when I do these problems, I draw pictures like this. It helps me think. I strongly encourage that you draw these pictures. I really, really feel like it helps to really visualize what's going on. In this solution, I mean, that's great. You could do it like that. It works, right? But it doesn't really give a very good description of how we're using this picture, okay? And that's why I say you need this picture, okay? This picture is going to help you a lot. Let me get rid of the circles for you. This picture is going to help you a lot. And the thing is, if you have this picture, you have to do less math. You could do it with just the picture of 68, 95, 99.7, right? But then you're going to have to be cutting stuff in half and figuring out what the missing part is. This gives you all those pieces. So all you're going to have to do is add up the pieces that you're being asked for when you're being given a problem. So this is a much easier way to interpret it. And if you guys have your notes and you're being asked a question, you have your notes in front of you, this is going to help you a ton. So if you're drawing it, great. If you're taking a picture of it, good. But you want to have this in your notes. So seriously, you want to have this in your notes. So Chevy Chase is there. I mean, nobody even knows who that is anymore. You do? Okay. Chevy Chase. Oh, that's not what that is. It's Chivs. I'm like giving a lesson in the Russian accent now. You don't like Russian accent? You're afraid of KGB. You're afraid KGB is nothing. I'm not scared of Gulag. No, I'm not today.
What's the best one?
You say like I'm scared of rock, you should like take the calculator and just like put it back in. Like somewhere it's like
The Gulag? That was anticlimactic. Guys, don't get intimidated by this. It's really simple. You have a formula. This is your formula, all right? If your standard deviation is 1, sorry, you're not going to use it for 1. You're only going to use it for numbers greater than 1. If it is 2 standard deviations from the mean, you'll plug in 2. And you get an answer. If it's 3 standard deviations from the mean, you plug in 3. You put that in your calculator and you get an answer. Alright? What if it was 2.36 standard deviations from the mean? What would you do? Plug in 2.36. It tells you how much data that is, okay? Alright? Not bad. Yes. Oh, sorry.
Mr. Drummond, do you think that's most painful? Mine hurt like it's right here.
Okay, the age distributions for Alaska and Florida shown in are shown in the Instagrams. I do not see the Instagrams. Okay, so then our standard deviation is going to be 1 minus 1 over. Yes. No problem. Easy peasy. And there it is. Yay. And we didn't have the histogram, so. If we have some group data, like classes, right? We have a new formula for our standard deviation. Not sure why you would. It's not just ungroup the data, you get the standard deviation. But there we go. If you have the data, you can do whatever you want. He's super careful in that thing. Alright, and then you can find this data, group data using standard deviation using your calculator. And this is the assignment, which we'll work on next class. Thanks.